Okay, welcome back to the channel. In today's video, we are covering section B, machine learning concepts, where we match terms from column A to their correct definitions in column B. I'll not only give you the correct matches, but also explain each concept in detail so you understand why they go together. So let's begin. Manhattan distance matches with B options. So it is Manhattan distance is a distance metric where movement is restricted to horizontal and vertical direction. So just like navigating through city blocks in Manhattan, hence the name. Mathematically, it's the sum of absolute difference between the coordinates. This concept is corresponds to k equal to 1 in the Minkowski distance formula. It is widely used in clustering and nearest neighbor algorithms where the diagonal movement is not meaningful. So moving on to the next match, the column, Euclidean distance. For this, its correct match is A. Because Euclidean distance is a straight line distance between 2 points in space. It reflects the shortest possible path, just like a ruler drawn between 2 points. In generalized Minkowski form, Euclidean distance corresponds to k equal to 2. It's commonly used in KNN, K-means, and many ML algorithms. So third match, the column is Pearson coefficient. It matches to D. So the reason it is the Pearson coefficient measures linear relationship between two variables. It is calculated as covariance of x and y divided by the product of their standard deviations. Pearson is ideal when both variables are continuous and normally distributed, and when they want to quantify how strongly they move together. So next match, the column is Spearman coefficient. It matches with C. So unlike Pearson, Spearman does not measure linear relationship. Instead, it measures monotonic relationships by converting values into ranks. This makes Spearman ideal for nonlinear relationships, ordinal data without outliers, because ranking reduces the influence of extreme values. So the next match the column is L1 regularization, and it matches to its corresponding E in column B. Fifth. So L1 regularization used in lasso regression applies a penalty on the absolute value of coefficients. This creates sparsity, meaning it can force some coefficient to become exactly zero. Because of this, L1 is popular for feature selection, especially when working with high dimensional data set. So next match the column is 6. L2 regularization, it matches with F. So this. So L2 regularization applies to a penalty on the square of coefficients. Unlike L1, L2 does not eliminate features. It simply shrinks every coefficient smoothly and proportionally. This makes L2 used in bridge regression an excellent measure for reducing model complexity and preventing overfitting. Moving on to the next match the column, it is bagging, and it matches to G. So bagging stands for bootstrap aggregation. Here how it works. You can create multiple training datasets using bootstrapping, sampling with replacement, training a model on each dataset, averaging their prediction. Random forest is the most popular example of bagging. Bagging reduces the variance and makes model more stable. So moving on to the next match the column, it is boosting. It matches with H. So boosting builds model in sequence, not in parallel. Each new model tries harder to fix a mistake of the previous ones. This makes boosting extremely powerful, especially in algorithms like AdaBoost, gradient boosting, XGBoost, and light GBM. Boosting reduces bias and creates highly accurate predictive models. So now, ridge regression, it matches with I. Okay, so ridge regression applies a penalty of L2, which is the sum of squared applied on sum of squared multiplied by lambda. This penalty discourages large coefficients, helping the model generalize better. Ridge is ideal when most features contribute to the output. So next and last is this lasso regression. The only remaining is use penalty, lambda, and sum. So lasso regression applies an L1 penalty, the sum of absolute value of coefficients. This forces some coefficients to become exactly zero, which is effectively performing feature selection. It's best when you suspect that many features are not useful and want a simpler, more interpretable model. So let's quickly recap. One matches with A, two with one matches with B, two with A, third with fourth C, fourth with C, third with D, fifth with E, sixth with F, seventh with G, eighth with H, ninth with I, and 10th with J. So if this video helped you prepare for your exams or interviews, make sure to like, subscribe, and share it with your friends. Thank you for watching.